Okay, example 2 on the gradient of a curve. So it says, find the gradient of the curve and it's y equals 12 over the cube root of x at the point 1, 12. So they've given us the x and y coordinate of the point this time. In the previous example they only give us the x coordinate of the point. So we know the x and y coordinates of the point that lies in this curve. What we want to do is get the gradient of the curve at that point. So there's the key phrase, gradient. You should always think dy by dx, because dy by dx gives you the general gradient at any point. So we'll have our curve, and we know that we're going to differentiate to get the general gradient, but there's a problem. We've got a root in it, and we've got x in the bottom line. So we're going to have to do two things here. We're going to have to get rid of the roots, and then we're going to have to bring x to the top line. So let's get rid of the root first. So that's 12 over cube root of x is the same as x to the power of a third. Now we're going to shift x to the top line. Remember, you only ever slide x to the top line. So we're going to slide it to the top and change the sign of its power. So that's going to give us 12x to the power of minus a third. Okay, now we're in a position to differentiate, so we're going to get the general gradient dy by dx. So, in order to differentiate this term, we're going to multiply this term by the power. So multiply 12 by minus a third, so that's going to be negative 12 over 3. And then we're then going to put x down and subtract 1 from the power. Minus a third minus 1 is just going to be minus 4 over 3. And then we're going to cancel our fraction here, so that's going to give us minus 4. X to the power of minus 4 thirds. Now the plan, I've mentioned this before, is once you've differentiated and if there are any negative powers, please bring them back to the bottom line again. So I'm going to bring x to the bottom line and therefore make the power positive. So we're going to get minus 4 over x to the power of 4 over 3. You could put roots back in it as well. There's no issue with that. I'm just going to leave it like this for now. So we've got the general gradient at any point. What we want to do is get the actual gradient at the point 1, 12. So what that means is we're going to sub in the x coordinate of 1 into the general gradient to get the actual gradient. So actual gradient at the point where x equals 1. So chuck it in, we're going to get minus 4 over 1 to the power of 4 thirds. So what we're going to do then is we're going to take the cube root of 1 and then raise it to a power of 4. But I did tell you before that 1 to the power of anything is always 1, but we'll prove it here. So we've got minus 4 over, that's going to be the cube root of 1, and then all of that is to the power of 4, or you could just have 1 to the power of 4 underneath, it doesn't matter. So the cube root of 1 is just 1. Remember, when you take an odd root, there's only ever one solution to that, so that's just 1. And then 1 to the power of 4 is just 1, so we're just going to be left with minus 4. And that's it. That's the actual gradient at the point where x is equal to 1, or that's the actual gradient of the curve at the point where x equals 1.